In this video, we are going to discuss about elements of closed loop systems. So, in the what are all the elements of the closed loop system is available over here. That is the command, reference, input element, error detector, as well as control element, controlled system, feedback element. Okay, so these are all the elements. So that we are going to see now on requirements of good control system, and those are all the things we are going to discuss over in this particular video. Okay, so first we are going to discuss about elements of the closed loop system. First element is the command. Okay, what is the command? It is the external produced input and independent of the feedback control system, that is called command. Okay, so whatever the input system you are given, that is, you can say it as a command. So the external produced input and independent to the feedback control system is called command system. Then comes into the reference input elements. So it is used to produce the standard signal proportional to the command. So the whatever the required output we are going to provide, no, so that will be based on the this reference input element. So it is used to produce the standard signals. And comes into the next element, error detector. So this error detector receives the measured signal, that means the output signal, and compares with the reference input. The difference of two signals is called as error signal. So already we have seen in the last video. So like the feedback signal, it will be gives the feedback signal that is going to measure with the reference input. So the difference between the two signals is called as error signal. So based on these error signals, the input has to be provided over towards into the controller input. So system is provided the signal to the controller over here. Okay, so the main use of this error signal is to make the system has to be provided the constant output over in the closed loop system. Okay, so it is compare the measured signal into the reference input signal. Okay, based upon that input signal has to be provided over here. Then comes into the control element. So the control element is to be regulates the output according to the signal obtained by the error detector. Okay, so the main aim of the control element means it is going to regulate the signals over here. Okay, that will be based on the error detector. So that is the function of the control element. Then comes into the controlled system. This represent what we are controlling, the feedback loop. Okay, so that is the controlled system. Then comes into the feedback element. This element feedback the output to the error detector for comparison with the reference input. So it is going to measure the output signal. Based on that output signal, it will be compared with that output signal into the reference input. Then it provides the error signal, that is the feedback element. Okay, so mainly this feedback element is used to maintain the constant output value. So that is the use of this feedback element. So example in this one means automatic electric iron. So once it will be reaches the maximum that required reference temperature, automatically it stop the heat passing over into the iron box. Okay, so that time what happens, the current it will be cut the current. So try to minimize the heat. Once it reaches the minimum heat, again start to supply the current. So again start to heat the coil, so that the heat has to produce in the automatic electric iron. Again it will reach as maximum, again the current flow it will be stopped. So this will be routine work, it takes place. And also the servo voltage stabilizer and sun seeker polar system, water level controller, and human perspiration system. So in the water level controller also it regulates that. Suppose the more water it comes, it provides the required water level only. So that it has to be controlled over here. Okay, so this is the you can give the examples for the closed loop system, and comes into the next thing, requirements of the good control system, that is the accuracy, sensitivity and noise. So the good control system has to provide the accuracy, that good accurate value, and sensitivity, it will not changes the values. The system is does not should not produce more noises, uh, and stability. So whatever the uh, things it may be affect the system, the external disturbances, the system should be steady, as well as the how many times if you are producing, it has to be provide the same values. Okay, that is stability. Then bandwidth, it has to provide the more data from transfer the more data from one point to another point. So bandwidth will be more in the closed loop system, and also speed, considerably it has to be more in the should be more in the good control system, and oscillations. So these are all the requirements of good control systems. Okay, so that accuracy, sensitivity, noise, stability, bandwidth and speed, oscillation. So mainly there is the good control system should not affect the external disturbances, and also it has to provide the accurate value, and noise, it should not produce the more noise over here, and also it has to be transfer the more data from one point to another point. That means the bandwidth has to be more over in the this type of closed loop system.